Hello, we will talk about three very basic and important notions in statistics. They are total probability, conditional probability, and Bayes theorem. These three are connected together and is the basis of learning Bayes statistics. So if we have events Bi, so B1, B2 to Bn, for example, and they make the universe for all the possible events, and each of them two are distinct or exclusive. So which means the union of Bi with Bj is 0 with phi. So phi is 0 events. So not possible they occur together. And now, if we want to know the probability of A, so A can be made as a summation of the probability. What is this probability? This is the union of A and Bj. Then we sum together all such kinds of union, then we can make A. So this is called total probability. If we look at this map, it may be easier to understand. So for example, B1, B2, B3, B4 are 4 events of people belonging to different age groups. For example, this is for 10 younger than 10 years old, and this is 10 to 30, and this is 30 to 60, and this is over 60 years old. So people can only belong to one of these 4 age groups. Then A, what is A? A is the event of having cancer. So now if we want to know the probability of people having cancer, then because we have additional information of the age, we want to know people having the probability of cancer, and we know the union of the probability of people having cancer in each age group. Then we can sum these probability together, and we can use the total probability function. So here we use the probability of people belonging to Bj, then times the probability of people belonging to Bj, people of having cancer, and given this group probability. So for example, this is 0.1, B2 is 0.2, and B3 is 0.3, and B4 is 0.4. Then we can use this probability times the probability of people having cancer in each age group. So, and this is the conditional probability. So conditional probability is the probability of A given we know the probability for the people belonging to this group, right? So this is the conditional probability. And this is the probability of Bj, and this is the probability of A given Bj. So we use the total probability and the conditional probability can get the probability of A. So now we can change the sequence for conditional probability. So we now want to know the probability of Bi given A. We can use the same conditional probability. Bi given A equals Pa and Bi's union divided by Pa. Because if we use this one times this one, we get the union of A, Bi, right? Because APA times PBI given A equals the union probability Pa and Bi. So this is also the conditional probability. Just we change the sequence from the previous page. Now we want to know the probability of Bi given A, not the probability of A given Bi. So this conditional probability for the denominator PA, we can use the total probability which we get from the first page. So this one, denominator, is the total probability. If we look at this one, right? This is the total probability for A. Or say the probability of A. We just use the total probability calculation. So PBI times the probability of A given BI, so sum together. Then we can put this PA in the denominator when calculating the conditional probability of BI given A. And the numerator is also can be written as a conditional probability times BI, right? So PBI times PA given BI, then divided by total probability. Actually, this product is part of the denominator, right? Is part of the denominator. Just denominator containing all projection of the PB and PA given B, right? So this is the conditional probability of A given BI. So this formula is called Bayes' theorem. Why we are interested in this theorem? Because in this theorem you can see this PBI is what we have the presumption of the probability of BI without knowing the probability of A. So this is usually called the prior probability. And when we have the information of A given BI, then we have the probability of BI given A. So this is called a posterior probability. So in Bayes statistics, is doing the job is from the prior, and this is the likelihood, and we get the posterior. So in the later videos for the Bayes statistics, this is the basic form we must understand. Thanks for watching.